Hello, hi, a very happy good evening. So this is Krishna Ma'am and we're talking about the story of life on earth, and that's biology. So welcome to the new beginning session. So we have been talking about transport in plants, and today we're going to solve numericals in this chapter. So in this chapter, we spoke about a lot of complicated terms, right? So what is water potential, what is pressure potential, what is solute potential? So yeah, a bit of confusing terms that seems devoid of biology, right? Well, so how can these be applied and what are the ways that the questions can come up? So here are the most possible questions from transport in plants. So let's see. So I have very simple questions that you just have to use a bit of your common sense, not all of your common sense, a bit of your common sense. So we have around 15-18 questions today. So let's solve them quickly so that you have an idea how the questions can come from transport in plants. Alright, so ready for today? So I know it's a Saturday evening, so all of you are looking forward for a weekend because things have been back to normal. So we all have tough and tiring schedules. So we are going to school, college, etc. So we have a tough schedule, but still it's okay. So please spare time to watch numerical videos, because in bio, students normally don't pay attention to numericals. So we just go for theory and theory and theory, but that's not how it goes. So we need to have some application also. So everywhere you have a touch of maths. So genetics is full of a lot of probability and statistics. Well, so we'll keep that for some other day. So today we'll talk about transport in plants, all right? Yes, so before we go into the questions, so I'll give you a quick recap of all the complicated terms that we spoke about, so that when you see the question, you're able to easily apply them, right? So please do like, share and subscribe, so don't forget to do that, and thank you so much for watching my lecture today. So let's move forward. So transport in plants, so we're going to solve questions from this topic. So let's move forward. So what are the complicated terms that we spoke, or what are the confusing terms which sounds off bio? So let's look into all the terms. So the first one, so we have been talking about water potential. So things started off with water potential. So water potential of pure water is 0. So water potential for a solution is always negative. So then we have solute potential. So solute potential is always negative. Then you have pressure potential, which is always positive. So thus the formula for water potential is given as water potential is equal to solute potential plus pressure potential. So this is the final formula for water potential. So then we spoke about a complicated term that is called as DPD. So before we go into DPD, so let's talk about DPDs. So DPD is also known as suction pressure. So this DPD has a formula. So DPD is equal to Turgor pressure minus, your osmotic pressure minus your Turgor pressure. So this is the formula for your DPD. So this is Turgor pressure, osmotic pressure minus Turgor pressure. So that is your DPD. So your DPD, when you talk about DPD, so that is the difference of the water potential. So that is the difference in the diffusion pressure of the water in the pure state to the diffusion potential of water in a solution state. So difference between both is called as your DPD. So when you calculate DPD, so water moves from lower value of DPD to higher value of DPD. So when you talk about osmosis, it moves from higher concentration to lower concentration. But when you calculate DPD, so which is the difference in the diffusion pressure of water in a pure state to that of water in a solution state, so it goes from lower DPD to higher DPD. So this is one point that you should always remember. Alright, so next we spoke about what is a plasmolysed cell, so what is hypertonic, what is hypertonic condition, so on. So let's quickly look into that and then we'll go to the problems directly. So first we spoke about a condition. So what if the cell is placed in hypertonic condition? So hyper is more, tonic is ion. So when you have more concentration of ions, so it is obviously understood that there is less concentration of water. So if your cell is placed in a hypertonic condition where the surrounding medium has less water, so water from the cell moves out, because inside the cell you have more concentration of water. So by the process of diffusion, water moves outside the cell. So thus the cell shrinks. So now this cell is known as a plasmolysed cell. So you get a plasmolysed condition when it is placed in a hypertonic condition, and this plasmolysed condition can be reversed when it is placed in a hypertonic condition, right? So in case of a plasmolysed cell, your Turgor pressure is negative. So thus your dPd, which is equal to OP minus Turgor pressure, because your Turgor pressure is negative here. So dPd is maximum in your plasmolysed cell. So I want you to remember this correlation. So then we'll talk about the hypotonic concentration. So hypotonic, so when you have less of ions and more of water. So the surrounding medium has more concentration of water. So water moves from outside the cell to the inside. So as a result, the cell swells. So when the cell swells, so this condition is known as the turgid condition. So in a turgid condition, it is maximum, right? So here, what you can say is dPd is equal to, so here dPd is equal to 0. Because your Turgor pressure is equal to your osmotic pressure. So here, thus your dPd is equal to 0 in a turgid cell. So the last condition is your isotonic condition. So isotonic, so you have equal concentration of ions and water inside and outside the cell. So there is no net movement of water. So hence in that case the cell is called as a flaccid cell. So in a flaccid cell your Turgor pressure is 0 because there is no net movement. So your dPd is equal to your osmotic pressure. So this is the final condition. Alright, so here your dPd is equal to the osmotic pressure. So these are some of the questions, some of the points that I want you to remember. So here dPd is maximum. So you should know where dPd is maximum, where dPd is 0 and where dPd is equal to the osmotic pressure. Alright, so let's move forward. So I have a question for you. So we start with the first question. So here is a question. So yeah, it looks like it has a lot of numbers, but don't get scared. So if a cell A with dPd has 5 bars is connected to cells B, C and D whose osmotic pressure, so OP is osmotic pressure and TP is Turgor pressure respectively. So the values are given. So now can you tell me the direction of flow of water in these cells? Yes? So what is the direction of flow of water in these cells? So how do you calculate? So you have 4 cells. You have A, you have B, you have C and you have D, right? So the dPd of your cell A is already given. So this is 5. So how do you calculate dPd? So dPd is equal to osmotic pressure minus your Turgor pressure. So the first value that is given is your osmotic pressure, the second value is your Turgor pressure. So this is for B, this is for C and this is for D, right? So we calculate accordingly. So for B it is 5 minus 5, so here dPd is 0, and for C it is 6 and for D it is 5. So now how is the movement of water? So remember your dPd, when you are calculating dPd, water moves from lower concentration to higher concentration. So the least is here, so it moves from B. First it can move from B to A, it can move to B to D and then it can move to B to C. So the flow of water, the direction of water is from B to A. It moves in this direction. So here when you look into all the conditions, so B to A is the right answer. So we go with option D. So I hope you understood how to solve these type of questions, right? So it goes from option D. So moving further, so question number 2. So which option is true for a fully turgid cell? So a cell is fully turgid when it is placed in a hypotonic condition. So we have a turgid cell. When the cell swells, so when the cell swells, it means it was placed in a hypotonic condition which has more amount of water ions, so that water moves inside the cell. So in a turgid cell, what happens is your dPd is 0. Why? Because in the turgid cell, your turgor pressure is equal to your osmotic pressure. So thus your dPd value is 0. So here option C is the right answer. Yes, are you able to understand how option C is the right answer here? Fine. So let's move forward. So question 3, the cell A has an osmotic potential of minus 20 bars and a pressure potential of 6 bars. So here the pressure potential is positive because always your pressure potential is positive, and the osmotic potential or the solute potential is always, so osmotic potential is negative, right? Yeah. So what will be its water potential? So water potential is equal to solute potential plus your pressure potential. So here it can be your osmotic potential as well plus your pressure potential. So when you do, it is minus 20 plus 6. So the answer is minus 14. But your osmotic pressure is equal to osmotic potential. The value is different, right? So here your water potential is minus 14 bars. And always remember, water potential is 0 for only pure water. When it means it has a solution, it is always negative. Fine? Okay. So let's go to question number 4. So to initiate cell plasmolysis, the salt solution should be, so when do you get a plasmolysed condition? So you get a plasmolysed condition when water moves out of the cell. So if this is my cell and when water moves out of the cell, so that is when the cell shrinks, and that condition is called as plasmolysed condition. So for a plasmolysed condition, it has to be placed in a hypertonic solution. So hypertonic solution means it has more salt concentration and less of ions. So water moves out of the cell into the surrounding medium. So here it should be hypertonic, right? So question 5. A plasmolysed cell can be deplasmolysed because plasmolysis is a reversible process by placing it in a hypotonic solution. So it is hypotonic solution by placing it in pure water or a hypotonic solution, so that water can move inside the cell and the cell swells up. So it is becoming deplasmolysed or it is becoming turgid, right? Yeah. So we go to the question 6. The hydrostatic pressure developed inside the cell on the cell wall due to endosmosis. So we have two types of osmosis, endosmosis and exosmosis. So what does this mean? So endosmosis is when water moves inside the cell. Endo is inside. So when I say exosmosis, it means water moves outside the cell. Fine. So this is called as the Turgor pressure or the pressure potential, because when water moves inside the cell, that is endosmosis, where the cell is having a lower concentration of water. So from higher concentration is moving into lower, from higher concentration is moving into lower concentration. There is a pressure exerted on the cell, so that is your Turgor pressure. Alright, so moving further, so in an apoplast pathway, water moves exclusively through. So we spoke about two types of transport. One is symplast and apoplast, right? So this symplast and apoplast is used for the transport of water from the root to the vascular bundles. So when it moves, so in apoplast, so how does it move? So it moves through the cell walls and it moves through the intercellular spaces. So both B and C are right. So for plasmodesmata, so that type of pathway is known as the symplast pathway. Right? Is it easy? Okay, so question 8, concentration of minerals in the soil is usually higher. That is why it moves through the active transport. So active transport is against the concentration gradient, right? So this is usually higher than the concentration of minerals in the root. So here higher is the right answer. So moving further, attractive forces of cell for water molecules is known as. So this is not attractive forces of water molecules. So this is attractive forces of the cell to the molecules. So that is the reason why your water molecules stay stuck to the tube of the xylem, right? So this attractive forces of the cell for the molecules, this is adhesion. So when the question is attractive forces of only water molecules, then that is your cohesion. When it says attractive forces of the cell for water molecules, so it is adhesion. Alright. Hello Shivam sir. So thank you so much for joining us today. So please do like, share and subscribe. Fine. So question 10. So again you have a numerical based question. So this question says in a fully turgid cell, so what is the condition? So you have a fully turgid cell when it is placed in a hypertonic condition, right? So you get a fully turgid cell when the cell swells. So when the cell swells, it means it is in the hypotonic condition. Sorry, it was placed in the hypertonic condition. So when the cell swells, what happens? So your DPD is 0 because in a turgid cell, your turgor pressure is equal to your osmotic pressure. So your DPD is 0 here. But in a flaccid cell, your DPD is maximum. Sorry, in a plasmolysed cell, your DPD is maximum. Alright, so let's move forward. So question 11. So in a flaccid cell, what is the condition? So a cell is called as flaccid cell when it is placed in an isotonic condition. So in an isotonic condition, there is no net movement of water, so turgor pressure is 0. So when turgor pressure is 0, so DPD is equal to osmotic pressure minus 0 because your turgor pressure is 0. So which means your DPD is directly equal to your osmotic pressure. So this is the right answer. So aren't the questions pretty easy? Yes? Hello ma'am. Yes, a very happy good evening. So thank you so much for joining my lecture. So please do like, share and subscribe. Alright. So this is a condition regarding the flaccid cell. Fine. So now let's move further. So question 12. So the turgor pressure of the plasmolysed cell is, so what is the turgor pressure of a plasmolysed cell? So remember, in a plasmolysed cell, the cell shrinks. So the cell shrinks from the cell wall, the contents of the cell shrink away from the cell wall or the plasma membrane. So meaning the water moves out of the cell. So the turgor pressure is obviously negative because the cell is going to shrink, right? So here your turgor pressure is negative. Done? So I hope you are understanding how to solve questions of these type. So let's move further. Osmotic pressure of a cell is 0 when? So what is osmotic pressure? The ability of a particular solute to stop the movement of the diffusing water so that the solution becomes diluted. So that is your osmotic pressure, right? So osmotic pressure of a cell is 0 in what condition? When turgor pressure is maximum? No, when turgor pressure is maximum, osmotic potential is also maximum, right? So this condition is not possible. When DPD is maximum. So DPD is maximum only when your turgor pressure is negative, not when osmotic pressure is 0. So this is also not possible. So your osmotic pressure of a cell cannot be 0 when your turgor pressure is 0. So when turgor pressure is 0, your osmotic potential is equal to your DPD. So even this condition is not possible. So nothing is possible here. So that will be the right answer. So it is not possible. Alright, fine. So let's go to question number 14. So opening of the stomata is due to what? So we spoke about the process of transpiration. So transpiration is the gaseous loss of water from the leaves, right? So this transpiration is made possible by a bean-shaped cell that is called as the guard cells that is present inside the stomata. So the opening of the stomata is due to what? So stomata consists of foci apparatus. So it has a bean-shaped cell like this. And surrounding it you have many cells like this. So this entire thing is known as your stomatal aperture. So you have chloroplast here. So yeah, so this is your stomatal pore. So now the opening and closing of this pore is guided by your turgidity of the guard cells. So what gives the ability to open and close is your turgidity of the guard cells. Fine? Yeah, so we come to question number 15. The rate of transpiration is high when the atmosphere is saturated with water vapor, because when the rate of transpiration is very high, the loss of water in your plants is also pretty high, right? So the rate of transpiration is high when the atmosphere is saturated with water vapor. The light is very dim, the temperature is very low. So obviously the atmosphere is saturated with water vapor, so then transpiration will be very low, because in transpiration water is lost as gases, so it produces water vapor. When the atmosphere is already saturated with water vapor, so why would transpiration happen? Not a sensible one, right? So we don't know anything about transpirations or any exact conclusive conditions, but still we can approximate because we know the logic, right? So light is very dim. When light is very dim, the temperature is very less, transpiration is not going to happen. So obviously light and temperature go hand in hand. So this is also not possible. So the rate of transpiration is high only when the atmosphere is dry and the temperature is very high. So when there is high temperature, when it is too sunny, then you also sweat a lot, right? So is the case with your plant. So then the transpiration also happens at its maximum. So this would be the right answer. So look, for the questions of these type where you do not know the exact answer, but you can use logic and eliminate the options. So guys, when you're solving questions in a national level exam, so make sure it is not only that you prepare so well that you know all the answers right away. No. So why is it the smart way to solve a competitive exam is to look into the option, because you know among the four, one is going to be the right answer and the other three are wrong answers. But you should feel lucky because these competitive exams have followed a MCQ pattern, because you have the answer right in front of you. So sometimes in a school test you feel like, oh God, I forgot that one word and hence I forgot the answer. So that is not possible in this case, right? But because you have the answer right in front of your eyes. So in that case, so you have the answer. So you should know how to eliminate the options to arrive at the right answer. So that is also one of the smart or the quick ways to arrive at the answer. So don't get scared when you don't know a question. So think logically. So try eliminating the options. That is one of the easiest way to get into the right way of attempting the questions, right? Okay, so I just have 2-3 questions left. So with that, we are done with today's question session. So I know it's a Saturday evening, even I want to keep the session pretty short. Right, so let's move forward. So question 16. So when the stomata, so I guess the has moved forward. So it is when the stomata are opening, we observe the following changes in the guard cells. So when the stomata is opening, what happens? The osmotic pressure increases, Turgor pressure decreases. The cell is opening. So when the stomata is opening, so the condition is the turgid condition. So in the turgid condition, what happens? So what happens in a turgid condition? So only one thing you know, in a turgid condition, so stomata opens so that water is lost, right? So during the day, stomata opens and water is lost, right? So which means when the stomata is opening, so water moves inside the stomata so that it becomes turgid. So the Turgor pressure inside the stomata increases, right? So now what happens? The osmotic pressure increases, Turgor pressure decreases? No, because Turgor pressure increases here. So this is technically wrong. Osmotic pressure and Turgor pressure increases. So the osmotic pressure as well as the Turgor pressure will increase when it is placed in a hypertonic condition only, when the surrounding medium and the cell has solutions inside it. But here your guard cell does not have a solution, so there is no chance of the Turgor pressure, the osmotic pressure to increase, right? So in that context, so it is the osmotic pressure decreases because, please note down the reason. The osmotic pressure decreases because there is no solution inside your guard cells. Only water is entering and your guard cell is perfect. It does not have a vacuole which has a membrane that is called as a tonoplast, right? So osmotic pressure decreases, your Turgor pressure increases is the right answer. So this is how it happens, right? So we are in question 16. So option C is the right answer. So Ranjan Maheshwari, hello. So after a long time, I guess you're coming to my session. So you were there with me in the previous batch. So I hope you're doing well. So have you given NEET exam before? Yes, did you give NEET exam on September 12th, or are you going to appear for NEET exam in the year 2023? But anyways, thank you so much for joining my session. So please don't forget to like, share and subscribe. Right, so I hope you understand. Okay, so you're going to appear for NEET exam in 2023. The S is for that. All right, so please understand. So you have to logically arrive at the answer. So the guard cells, when they open, that is when your stomata is opening, it means your Turgor pressure increases, but your osmotic pressure decreases. Fine. So let's move forward. So question number 17. The most important factor affecting transpiration is light, temperature, wind, atmospheric humidity. Okay, fine. So all the very best. So I hope you're preparing well. So please prepare well, and any point in time if you have a doubt in biology, so please feel free to ask me. I would be very grateful to help you. Right? Yeah, so the most important factor that affects transpiration would be a wind, because light and temperature both go in hand, and humidity is also the amount of moisture content. So here the most important factor affecting transpiration would be wind. So which direction the wind is blowing. So that is a very, very important case. So coming to the last section for the evening. So the conduction of water from the root hair to the xylem is which type of pathway? So which pathway it follows, whether it follows symplastic pathway or apoplastic pathway, or whether it moves osmotically from higher concentration to lower concentration across a semi-permeable membrane, or from symplastic to apoplastic. So symplastic means when it moves through the plasmodesmatal connections. So that is, it moves through the cytoplasm, right? So apoplastic is when it moves through the cell wall plus the intercellular spaces. Right? So or symplastic or apoplastically. So when it moves from the root hair to the xylem, so from the root hair till the region of your cortex, it moves through your symplastic transport, it moves through your apoplastic transport. So from cortex to your endodermis, again it is apoplast. But when it moves from your endodermis to your xylem, that is your vascular bundle, it has to choose the apoplast way, because you have what is called as Casparian strips, and your Casparian strips are very impervious to water, right? When bone got fractured and not taking treatment caused which disease? Okay, when your bone gets fractured and you're not taking treatment, which causes which disease? So when a bone is fractured, the pain is unbearable. You cannot be without treatment. So you just go to the doctor at least to get a painkiller, and then the doctor will definitely find out that it's a fracture. You cannot stay with a bone that is fractured, because that causes immense pain. So because that pain is unbearable, even a small ligament tear pain is unbearable, that you run to the doctor. But when a person has a fractured bone and is not going to a doctor, so that is a very, very weird condition, so that would not happen. Okay, Ranjan? Right, so here the right answer would be symplastic as well as apoplastic mode of transport. So this is all that I have for today. So I hope I have taught the tricky part of transport in plants in an easy way. I believe so. So please go through my lecture. So it's a continuation, and for all those who are coming to my lecture for the first time, so I teach class 11 and class 12 parallelly. So Monday, Wednesday and Friday I teach class 12. Tuesday, Thursday, Saturday I teach class 11. So today was Saturday and we are talking about transport in plants. So I thought I will have a problem session here, so that's hence we had this session. And regarding next week, so Monday we'll continue with sexual reproduction in flowering plants, and Tuesday we'll finish off your transport in plants. And for all those who have been asking me for a Menti quiz, so next week Thursday and next week Friday we have a Menti quiz at exactly 5:15. So on Thursday we have a Menti quiz in neural control and coordination, and on Friday we have a Menti quiz in sexual reproduction in flowering plants. So I request a lot of you to join the Menti and make it a very, very active event. So thank you so much. So have a splendid weekend. So I guess this is my last slide. Yeah, so if you genuinely liked my way of teaching and the way I taught you how to solve problems, so if it's really good, so please do like, share and subscribe. So class timing is 5:15. So I start my class at 5:15. So since I go topic wise, so it depends on how long the topic takes me. So please join me at 5:15 every day, and on Thursday and Friday of next week, that is 1st and 2nd of December, 2nd and 3rd of December, so we are having a Menti quiz. So on 2nd, that is Thursday, the Menti quiz is on neural control and coordination. You have 25 questions at exactly 5:15. And on Friday, that is of 3rd December, so the topic is sexual reproduction in flowering plants. So again, you have 25 questions and the time is 5:15. So please join me for the same. So thank you so much for watching my lecture. Have a great weekend ahead. So this is me signing off. So I'll meet you on Monday at 5:15. So talking about double fertilization. So until then, I'll catch you up. Thank you. Bye.